me take a couple more examples. Let us see this example that has again the piecewise function. Okay, what does it say? Fx equals to negative 5x if x is lesser or equals to 2, and for x greater than 2 it takes this value. Okay, both of these p's have x. Okay, now you see that this is a polynomial function. This is a degree 1, right? This is a linear function, this is a quadratic function, so they must be continuous everywhere in their domain, but the domain is all the values less than or equals to 2, this is that function, and for x greater than 2 this is that function. So this function is continuous everywhere, but we want to check, and this function is continuous everywhere in its domain too, but here the boundary is 2, right? On the left of 2 it takes this value, on the right of 2 it takes this value. At the boundary, now we doubt on the boundary. On the boundary it may not be continuous, we will check. Okay, so how do I check that? Is we find out the left limit. So solution is, let's find out the left limit at 2. X tends to, so x tends to 2 minus, okay, because at 1, 0, negative 1, negative 2, negative 3 it is continuous because it is a polynomial function. At 2 may not be because this function go up to 2 only, and after 2 on the right of 2 another function starts, so they may have limit may not exist, or the functional value may not be equal to the limit. So we want to check that, but everywhere except 2 the function is continuous, okay, because they are the polynomial function. So fx, so I want to find out the left limit of the function fx. What I do is limit x tends to 2 minus, which p should I pick? Left means all x less than 2, so you need to pick this negative 5x. Okay, although this is 2 to the negative, you just plug in 2, so that will be negative 5 times 2. You don't plug in negative 2 because it is 2 minus means it is 2, but from the left side slightly smaller than 2 might be, that's why I just put almost 2. So negative 5 times 2 is negative 10. The left limit is negative 10. How about the right limit? Limit x tends to 2 plus fx is, so limit x tends to 2 plus, which p should I pick? The second, right? Because all values of x greater than 2, this is the function. So you do x square minus 4x plus 7. What you do is you plug in that 2. So 2 square minus 4 times 2 plus 7. How much is 2 square? 4 minus 8 plus 7 is how much? Is that 4 minus 8 is negative 4 plus 7 is 3. So the left limit is not equals to the right limit. So the limit does not exist. So limit does not exist means the function is not continuous. Although you can find out what is f at 2. What is the functional value? Which piece should I pick for the functional value? You are right, the top piece, because it says equals to 2. X is less than or equals to 2. Equals to 2 means that is the place, that is the piece you pick the functional value. That is negative 5 times 2 equals to 10. So the limit does not exist. They are not equal, right? This is not equal to that one. So the limit does not exist means the function is not continuous. So basically it has non-removable discontinuity. So not continuous. I would say non-removable discontinuity. So if the function is not continuous, then you may want to decide whether it is removable discontinuity or non-removable discontinuity. All right, let us do this example. If fx is continuous everywhere, it says the function is continuous everywhere. Okay, then find a and b. So if the function is continuous everywhere, it must be continuous on those boundaries too. So what we do is there are a and b. Okay, so the left limit at 2, let's check left limit at 2. So since it is continuous, limit x tends to negative 2 minus fx is equals to limit x tends to negative 2 plus fx. You see that? Because they are continuous, so the limit must exist. Okay, the limit must exist because they are continuous. Now let's plug in that. So which function should I pick for the left limit at negative 2? 6, right? So this value is 6. You see that? Because for the left limit you pick this function, there is no x, so you don't have to plug in that negative 2 minus, just write down 6. On the right limit at -2, this is the piece where the right you go from -2, you go to -2 from right. Okay, so it is a times -2, a times you plug in that -2 plus b. So what do you get? You get 6 equals to negative twice a plus b. That's what you get. Do you understand that? Okay, so the next thing I want to do is let us check the continuity at positive 4. For positive 4, so limit, why do I know that they are equal? Because it says the function is continuous everywhere, so it must be continuous at -2 and positive 4. Limit x tends to 4 minus fx must be equals to limit x tends to 4 plus, or you can just write down the f4 also, that is also fine. F of x. What is 4 minus fx? Which piece should I pick? I pick this piece, right? And then you plug in x equals to 4. So 4a plus b equals to, there is -6 on the right, because for x greater or equals to 4, you pick that piece. Now you got two equations, right? Equation 1 and equation 2, right? So equation 1 and equation 2. So this is equation 2. Now you solve those two equations. How do I solve? You add or subtract, right? Let me subtract the second equation. There is negative twice a plus b equals to positive 6. I want to subtract. Subtract means subtract this and then subtract that. You cancel out. You cancel out those two. What do you get? 4a plus 2a is 6a equals to, you are also subtracting here, right? Negative 12. So what do you get? You get divide by 6 on both sides. You get a equals to -2, right? And to find out b, let me continue here. So you plug in one of the equations. So let me use a equals to -2 in equation 2. What do you get? You get 4 times -2 plus b equals to -6, right? So -8 plus b equals to, you get -6. Now add 8 on both sides. What do you get? Add 8 on both sides. You will get b equals to positive 2. So a is -6 and b is positive 2. That is the values of a and b. So that if you plug in -2x plus 2, then the left limit and the right limit at -2 and the left limit and right limit at positive 4 are equal.